If you've spent any time watching the aquarium content online lately, you've probably noticed two major problems that dominate this hobby. First, planted tank advice has been completely hijacked by terrestrial gardening jargon that doesn't even apply to submerged aquatic plants. Creators treat a fish tank like a backyard dirt garden, pushing land-based soil concepts, complex terrestrial nutrient ratios, and high-maintenance substrate routines as if your aquarium was a patch of tomatoes in the backyard. Second, shrimp keeping advice has turned into a high-stress FOMO scam. Every video thumbnail is framed like a panic attack. Creators talk as if your colony is constantly one hair away from a total mass casualty event, or conversely, that you're just one secret product or trick away from waking up to 10,000 baby shrimp in a 10-gallon tank. I run aquariums with all types of substrates, but I frequently showcase bare-bottom planted tanks for one simple reason. It proves visually that any aquatic plant can thrive without a single grain of dirt or gravel. We're going to take a look at actual aquatic root biology, break down why popular substrates like sand can actually hinder your plant growth, and review official lab test results on fish waste and dismantle the marketing traps being pushed on the hobby. Let's start with basic biology fact that the aquarium industry ignores. Submerged roots do not work the same way as land roots. Look at a common houseplant like pothos. Everyone knows you can take a pothos vine out of a pot of dirt, stick it in an aquarium, and it will pull nitrates directly out of the water. But watch what happens to the roots when you do that. The terrestrial dirt roots that grew in the pot will melt and die off in the water. In their place, the plant grows entirely new, specialized aquatic roots. If you take that same pothos months later and plant it back in land soil, those aquatic roots melt and the land roots grow back. Why? Because roots physically adapt to their environment. In our aquariums, aquatic plants don't eat dirt and they don't eat sand. All aquatic plants, whether it's an epiphyte like Anubias, a stem plant, or a supposed heavy root feeder like Amazon sword, they're capable fully of absorbing dissolved ionic nutrients directly from the water column through their aquatic root cells and leaves. Think about how a new cutting works. If you take a fresh pothos cutting without a single root and place it in a plain glass of tap water, no dirt, no fish waste, no fertilizer, it doesn't instantly die. It uses simple dissolved minerals, light, and ambient carbon dioxide to sprout long aquatic roots and push out new leaves. If a houseplant cutting can do that in plain tap water, why are we told that aquarium plants will perish without $50 worth of specialized soil or root tabs placed every 3 inches? They won't. The hobby has treated aquarium plants like land plants because consumers buy soil and fertilizer. A fully informed hobbyist realizes that submerged plants drink from the water solution they sit in. This brings us to the substrate debate and why certain popular substrates can actually act as a hindrance to your plant roots. Take pool filter sand, which is constantly recommended to beginners online. What is pool filter sand designed to do in a swimming pool? It's designed to trap physical dirt and stop it from passing through. When you put fine sand in an aquarium, it does the exact same thing. It forms an impenetrable barrier. Physical fish waste and detritus sit trapped on top of the sand, while the water trapped beneath the sand layer becomes completely stagnant. Because there's zero water circulation through the compact sand, fresh nutrients cannot reach the roots buried below. Roots don't consume solid sand grains or solid root tab clay. When you put a root tab into sand, it simply dissolves into that trapped, stagnant pocket of water, and the roots drink from the water surrounding them. Now compare that to a gravel or bare bottom setup. Gravel leaves open spaces for water movement, allowing detritus to naturally work its way down where microbacteria break it down into a liquid solution into the water. And what about the popular trend of putting land or garden soil underneath sand? Every online influencer will tell you that fish waste is liquid gold, but none of them can tell you what's actually in it because they've never bothered to test it. I took organic fish waste from a low-tech, non-fertilized home aquarium and sent it to a certified soil and wastewater analysis lab. The lab assay proves that natural, microbially decomposed aquarium waste contains a full spectrum of plant nutrition: primary nitrogen, phosphorus, potassium, calcium, magnesium, iron, and essential trace minerals. Now, how much fish waste do you need in your tank? The honest answer is, the answer content creators hate to give, is that nobody knows for your specific tank because every single aquarium is an independent ecosystem. Two identical 10-gallon tanks sitting side by side in the same room will have different nutrient demands based on livestock density, feeding amounts, plant biomass, tap water mineral profiles, and lighting duration. If you add pressurized CO2, which acts like a turbocharger for plant metabolism, your plants will demand significantly more light and nutrients. But the vast majority of fish keepers in America run low-tech aquariums without CO2 injection. In a low-tech aquarium, carbon dioxide is your limiting factor. In most cases, the natural waste produced by your fish and shrimp provide more than enough nutrition for low-tech plant growth. The mistake beginners make is adding 5 different variables on day 1: specialty dirt, liquid fertilizers, root tabs, and chemical additives, before giving the tank time to establish. When you add 5 variables at once, you have no idea what's working and what is causing your algae bloom. The correct scientific approach is to cycle the tank, add your livestock, and simply wait. Let the fish waste accumulate. Let the bacteria break it down into a solution, and watch how your plants respond before dumping money into chemical quick fixes. As viewers gain access to better tools, and as people start asking simple, objective questions about video content, the era of overcomplicating basic fish keeping for ad revenue is coming to an end. You don't need expensive substrates, root tab schedules, or proprietary plastic gear to keep a beautiful aquarium. If you want to see the exact laboratory breakdown of aquarium waste and how passive nutrient transport works in detail, check out my video on the substrate lie, linked right here. Subscribe to Aquarium Authority for real science-backed fish keeping without the marketing noise. Thanks for watching, and I'll see you in the next one.